This video demonstrates how to run cluster analysis, discriminant analysis, and classification analysis with MEXL by Decision Pro. It is intended for Marketing DSO 566 students of Marketing Analytics. In this demonstration, I will demonstrate cluster analysis, discriminant analysis, and classification analysis in that order. We will begin with cluster analysis alone. To do this, I will demonstrate on the tutorial data provided by Decision Pro, which utilizes data from a fictional office supplies retailer known as Office Star. To run cluster analysis, we use the MEXL add-ins, segmentation and classification, run analysis. The first step will be to determine how many clusters are naturally occurring in the data. We will select 9 because 9 is typically more than occur in most applications. Note here the possibility to standardize data. This is necessary if the data are on different scales. With this data, they're all on a scale of 1 to 10, so we do not need to standardize, but most applications require some standardization. This tab, first column, contains respondents' IDs, simply as an indication that we are going to include the respondents' IDs here in the leftmost column. Discriminant data, this step we will disable as we are only doing cluster analysis. I suggest you always keep this toggled, statistical differences, as this gives highlighting to indicate which averages are statistically significantly different than the cluster averages. Once we're satisfied with this dialog box, we can input our data. Please select segmentation data. This prompt asks us to highlight the segmentation data, in particular as we include the labels of all our basis variables, as well as the respondent IDs for all respondents, in this case 40. The software opens a new workbook, Book 1, with 3 tabs. The Segmentation Data tab reproduces the data that was used in the analysis. It provides a check to make sure that you've entered the data that you wanted to enter. All 6 variables have appeared here, and so have all 40 respondents. The Dendrogram tab will be used to determine the number of clusters we want to use or retain in the subsequent analyses. Based on this dendrogram, as we discussed in class, 3 seems like the best number to use, so we use 3 clusters in the subsequent analysis. The final tab, segmentation, is not of use to us now because we're only determining the number of clusters. We will have 3 clusters, but this has displayed averages in the 9 clusters assignment, which is the one we're not choosing. So now that we've chosen 3 clusters to use, we will now do the analysis with discrimination data to better describe these 3 clusters. So returning, I switch windows to our data. We run analysis once more. We'll use hierarchical clustering now with 3, so we change number of clusters to 3. It's the same data. First column contains respondents' IDs. Now we enable discriminant analysis. Now we will be prompted again for the segmentation data, just as before. But we will now be prompted for additional data, namely the descriptor variables professional age and income for these same respondents. Again, we will highlight the respondent IDs as well as the variable labels. A second workbook will be created now with 5 tabs. The segmentation data and the discrimination data again are retained as a check to see that the data were entered correctly. A dendrogram tab will also be produced, but this is no longer necessary because we've determined the number of clusters to use. The output that will be most relevant for us will be the segmentation tab and the discrimination tab. Under the segmentation tab, we have the cluster sizes. There are 3 clusters with different numbers in each. The segmentation variables give the average within the cluster and overall. The highlighting here gives statistical significance of a t-test between the cluster average and the overall average. We see here that cluster 1 on this first variable variety of choice is statistically different than the overall average. The green indicates that it's higher, whereas the red indicates that it's lower. Non-highlighting means there's no statistical difference between that cluster's variable and the overall. Scrolling down, the cluster members gives the assignments of each respondent to a particular cluster. Now to the discrimination tab, which provides output statistics that indicate how well each of the descriptor variables describes the clusters and in what way. The cluster sizes here are repeated from the segmentation tab. The discrimination variables here give the average of each of the descriptor variables overall in the whole data and within each cluster. Here we see, for example, that the average age of cluster 2 is around 31 years of age compared to the overall of 40.5, which is statistically lower. The discrimination averages and the discriminant functions together, and these correlations in particular of the descriptor variables and the discriminant functions, help us interpret how to describe each of the clusters in terms of these discriminant variables. How to do this was described in class. Finally, we have the confusion matrix, which gives an indication of how well our descriptor variables predict cluster membership. These 2 matrices provide the same information, the upper one demonstrating it in absolute terms or count data, the lower one on a percentage basis. The horizontal line here for cluster 1 indicates the actual as indicated or defined by the cluster analysis. The vertical columns here indicate the predicted cluster assignments by the descriptor variables. Again, actual is defined by the cluster analysis, predicted by the discrimination analysis. So for example, in cluster 1 we have 10 plus 3 plus 5 or 18 as indicated here by the cluster analysis. However, discriminant analysis predicted 10 in cluster 1, and of those, actually in cluster 1 it predicted 3 in cluster 2, and of those in cluster 1, discriminant analysis predicted 5 of them in cluster 3. The confusion matrix on a percentage basis gives us a percentage of how well we do with descriptor variables. For cluster 2, for instance, we have a hit rate of 92.9%. In other words, we had 13 out of 14 predicted correctly by descriptor variables. Cluster 1 and cluster 3 around 55%, which is not as good. Now, underneath the confusion matrix, we have 2 more matrices. These are not used to interpret the data. However, these statistics or output are used when we use classification analysis, which I'll demonstrate now. To run classification, we run classification on a new set of discriminant variables or descriptor variables, say in another market where we don't have segmentation variables. To do that, we retain these outputs and go to the original data, which has classification data. We run MEXL, segmentation, and classification, but we do not run analysis, rather run classification. A dialog box pops up asking us whether we want to include the first column as respondents' IDs for our data. Yes, we will include that. Now it prompts us for classification weights. The classification weights, if you recall, occurred and as output in our discriminant analysis, which was book 2. We highlight the whole matrix, not just the output statistics, but also the labels of function 1 and 2 and the clusters. It will then prompt us for classification coefficients. We do the same for this matrix, highlighting the labels as well as the numbers. Finally, a dialog box will appear asking us where the data is. Go back to the original file. Now don't be confused when it says please select discriminant data. Discrimination data and segmentation data were used for the cluster and discriminant data analysis together. Classification analysis is done on new discriminant data, which is provided in the classification tab. You see these are new observations on descriptor variables. So because we're including respondent IDs, we include that column as well as the labels for each of the variables, highlighting for all observations. Once that's entered, the analysis provides output, simply this column, which is the predicted cluster. So for instance, customer 1, the analysis indicates that these values of the descriptor variables suggest that they belong to cluster 2 as defined by the cluster analysis. That's the only output from classification analysis. This concludes the demonstration of cluster analysis, discriminant analysis, and classification with MEXL.